We want to look at methane, and this is these are ball and stick models, is what they're called. The black is representative of carbon, and the white is representative of a hydrogen atom. Okay, and methane is CH4. So, and the way I'm putting these in, I'm turning this clockwise as I put it in. And I need to do the same on this other one, clockwise. And what's weird, you think you turn it counterclockwise to get it out, but you don't. You turn it the same way. You turn it clockwise when it's time for us to take those out also. Okay, so it's CH3 so far. Need another bond, turning it clockwise, turning the hydrogen clockwise, and voila, we have a molecule of methane. Okay, methane gas. This is what's used to heat our homes and everything. And the shape of it, you have to think, it's these four sections, the S's, the PX, the PY, the PZ, these four different areas. The electrons, they're flying around the carbon, attracted to the carbon, but boy, they hate each other's guts. So they're spread out as much as they can possibly be, all right? That's what we would call a pyramidal shape, or a tetrahedron. Okay, and methane is a classic example of an AB4 molecule, or its formula is, as I said, CH4. Okay, for this next molecule, we're going to make it what's considered an AB3 molecule, or these one we'll use is NH3, ammonia. It's strong, nasty smelling stuff. If you remember sketching out Bohr models, nitrogen was 2 on the first, 5 on the second, and which means it wanted 3 more. Okay, it wanted 3 more bonds, right? Because it already had one set bond. Now, here's one way that we do that. We'll leave the S, the 2 electrons make up an S. They're already there. It was a 2s2, 2px1, py1, pz1. A 2s2, 2px1, 2py1, 2pz1. It's sharing an electron with the hydrogen, and it's kind of that pyramid shape, except I don't have a 4th hydrogen up here because I've got 2 electrons. Okay, it doesn't need to share. All right, there's a pair of electrons up here already. So I need 1 more in the px, 1 in the py, 1 in the pz. All right, and that's what it does. So this is a variation of the tetrahedron called a trigonal pyramidal shape. Is what it's called. But this is an AB3 molecule. An example that you're familiar with is ammonia, NH3. Pause. All right, another one that I mentioned yesterday, just in some of the sketches, the red is an oxygen, all right? And right now you're breathing in a lot of oxygen. And we said that Bohr models, sketching Bohr models, are not really good at, it's not the best way to sketch double bonds. It doesn't work. These ball and stick models are much better with that, because we can bend it some, and we're showing this oxygen that we're breathing in is double bonded to itself. So this is O2, or what's known as molecular oxygen. Bohr model, it had 2 electrons on the first shell, 6 on the second. So it wants to share 2 electrons. It shares one with an oxygen and another one with that same oxygen. So this is what we are breathing in. Okay. What we're breathing out right now, could you hand me that, please? Once the oxygen comes in, okay, mitochondria burn it up, and they change it. They break those covalent bonds, and we get a lot of energy coming off those bonds. And one thing that's left in form from that is carbon dioxide. Okay, or a carbon will double bond to an oxygen. And each carbon, as you can remember, as you see from this one, each carbon wants to bond 4 times. It's 2 on the first, 4 electrons on the second shell. It wants to be bonded a total of 4 times, and that's what we have in this one. Well, here's another way that it's going to be bonded 4 times. It's going to bond once to that oxygen, once to that same oxygen. To the second oxygen, it's going to bond once, it's going to bond twice. Voila! This is CO2. Let me get these other molecules out of the way. This is a molecule of CO2. Okay, carbon double bonded to each oxygen on the side. This is what we are exhaling. So tremendous energy in these covalent bonds. All right. Let's do a hydrogen bonded to another hydrogen. I'm gonna get one of these smaller springs because the oxygen, it's sharing electrons with each other. They both have 1 electron. Wow. If it had 2 electrons on that first shell, that would be happy, stable, content. And that's what it does. Okay. It shares an electron with the other one. So both of them think that they have 2 electrons going around them right now. Okay. 1 electron from this one, 1 electron from that one. This one has 1 electron from this one on the right, 1 electron from the one on the left. Okay. And so they both think they have filled outer shells. So sharing electrons, covalent bonds, we can call this a molecule now. This is an H2 molecule. We think it's the most abundant element, the most abundant molecule in the universe, and the smallest molecule in the universe. Okay, so this is molecular hydrogen, or also known as diatomic hydrogen. Okay, and we want to do one more. This makes up about let's see, oranges were nitrogens. Almost 80% of what you're breathing in when you take a big breath, you're breathing in molecular nitrogen, okay? And it's triple bonded. When you sketched out nitrogen, it's 2 on the first, 5 on the second, okay? So 1 and 3 more, all right? If 2 nitrogens bump into each other, they can actually get those 3 electrons by sharing with each other. So 2 nitrogen atoms will typically do that, right? And it's going to be a triple bond. There aren't too many things like that, but boy, that is a strong arrangement. It takes a ton of energy. We inhale it and we exhale that stuff. Our lungs don't get to break down any of those bonds, okay? All the nitrogen that we need, we get that through our diet, through it basically starts with atmospheric nitrogen going down into the soil and the roots of certain plants. There's bacteria that slowly break it down into nitrates and nitrites, which you know those things. So I think this is the next thing we're going to look at, is just what happens to the nitrogen once it gets in us. So this is N2, or molecular nitrogen. Okay, it wanted 3 electrons, and it gets it by sharing 1 of its own, basically sharing 3 of its own and gaining 3. So that's it with this. Thank you very much.